Alright, so we're going to get started today with some of our vocabulary, and some of this is a review from our last set of notes. We have the word proportion, ratio, scale drawing, and scale factor. Those are repeats from last time, but take a minute to read over those to refresh your memory. And then we also have two new words. We have congruent, which means that two shapes are the exact same size and shape. And we have similar shapes, which are defined as corresponding angles are congruent and corresponding sides are proportional. So they're going to look the same, but they're not the same size. In addition to some new vocabulary, we also have some new symbols that we're going to be using. The first one is defined as similar to. So you could use it in the sense of saying two triangles are similar to one another. So triangle ABC is similar to triangle DEF. And we're going to use this for all sorts of shapes. But that notation that I just used above for that with that triangle shape in front of the letters, that's called triangle ABC or whatever letters you have there. And that's just used to denote that we're talking about a triangle. Here's a picture of our triangle with points A, B, C. Those are the vertices. So that's what we call those shapes. The next symbol that we have are two letters with this line on top of it, and that's read as either segment DE or side DE. So that would be in the case of if you have a shape. In this case, we have a parallelogram. This side, from where we have point D all the way down to point E, that would be side DE, and you're going to represent it using that line over the letters there. The next symbol that you're going to see is this little angle shape, and then three letters. So this one is called angle HIJ, and the order does matter here, so make a note of that. And as an example, here's an angle here. We have HIJ, and that's how we read it in that order. The I, that is our middle letter, and that's always going to be that point that's at the tip of our angle, not those ones that are on the outside. So HIJ is read in that order. So it'd be the measurement right in here. And the last symbol that we have down here is that equal sign with what looks like the similar to symbol on top of it. And all together, that is called congruent to. So you could use it to say that two triangles are congruent to one another. Triangle ABC is congruent to triangle DEF. And remember that congruent means that they're the same shape and same size, whereas similar just meant that they're going to look like the same shape, but they're not necessarily the same size. Feel free to pause the video here to get down the rest of these notes. Alright, as we move on to the second page, we have this example that says complete the congruent statements below. And right off the bat, they tell us that these two triangles are going to be congruent to one another. That means that they're the same shape and they're the same size. It also is important to note that we have triangle ABC is congruent to DEF. The order there does matter. So to show this order, we're going to use different colors, and if you don't have different colors, you can just do the different lines to indicate which points are related to one another. So A comes first in both of these, in this first triangle, and then D is first in our second triangle. So I'm just going to use one line to represent each of those. And then B comes first or second in our first triangle, and so I'm going to use two lines to show that. And E comes second in our second triangle. So that's also going to get two lines in that same color there. So that means that angle A and angle D are corresponding, angle B and angle E are corresponding, and last but not least, C is the last letter in this first triangle and F is the last letter in our second. So that means that angle C and angle F are each going to get three lines here and have the same colors representing them. So I would always just mark each of those angles the same when you're getting started with one of these problems. And now it's trying to have us figure out, well, which angle is equivalent or is congruent to angle A, and we marked angle D the same there, so that's going to be angle D right there. Angle E we marked the same as angle B, and angle F we marked the same as angle C. So right away you can fill in those answers real quick because we already marked them based on the order. Now the side links are pretty similar, so you want to just take it in the same order. So since AB comes first together, that's going to correspond to those first two letters that are next to each other in the second one, so DE. And we can mark those sides with each one tick mark right there. That's going to show that those sides are corresponding to one another. So BC, those ones come next, and EF, those come next together too, so those are corresponding sides. And then side AC, that's the first letter and the last letter, that's going to be corresponding to side DF. That's also the first and last letter of that other triangle. So we're going to mark each of those with 3 tick marks. Then we can go fill in which sides are corresponding. So AB we said was the same as DE, and don't forget to put the little line over it. EF we said is the same as BC, and then AC will be the same as DF. Now before we move on, it's important to remember that when figures are similar, only the angles are congruent. The side lengths are only going to be proportional. So when figures are similar, they're going to have that same angle measure, but their sides will be not the same length, but just in proportion to one another. In our next example, the directions say to select all true statements regarding the similar figures represented below. So right off the bat, they're telling us that these are similar figures, but we have to determine which of these are going to be true statements. And since we were told they were similar, I went ahead and I marked those corresponding corners. So you can either use different colors to mark yours, or as we talked about before, you can always draw the little lines like this to show, and then 1, 2 like this, whichever way works better for you. Once you mark them, it's going to be easy to tell the order which they're telling us. So if we look at this first statement, it says A, B, C, D is similar to G, H, E, F. So you just want to look at the order there. A, B, that works with G, H, that looks good. B goes to C, and H goes to E. C goes to D, and E goes to F. Since all of those were in the same order there, that is going to be true. Taking a look at our next one, we have B, C, D, A. That means that they're starting up at this orange corner, and they're going to say that H, E, F, G will be similar to that, and those angles did go in that same order, so that's going to be good for us. And looking at that last one, F, E, H, G. So they're starting down at the green one and going all the way counterclockwise to G. And it looks like that's going to be similar to A, B, C, D. And that's actually going the opposite way and not starting at the same corresponding angle, so that is not going to be true. Taking a look at the next one, we have angle A is congruent to angle G. And we already marked that those were both the same color, the same line there, so we do know that those are going to be congruent. And then we have side length. AB is to side length GH, as side length CD is to side length EF. So AB right here, they're saying is to GH. That looks good. Those are both the left side of our shape there. And then they said that CD, so that's over here, will be to EF. And that order looks good. Those are both corresponding sides, and they went from one triangle to the other, and the first triangle back to the other one. So the order there is all lined up nicely in a proportion, so that's going to be true. Now the last one here, we have BA is going to be to HG. That looks good. We already marked that those were right. Those are both still the left side of our shape. That looks good. But then here it says FE is to DC. So FE is to DC. Now, that looks like it's going to be good, but there's one thing that they're trying to trick you here with. So this right here, BA, came from the same triangle that DC came from, whereas HG, this side length, came from the same triangle as FE. And remember, in our proportions, we need to be lined up horizontally across, so they should be coming from the same shape, and since they're not, this is not going to be true. So taking a look at our next example, it says determine whether the pairs of triangles are similar. And if triangle LMN is going to be similar to triangle STU, the two triangles we have here, then the following must be true. And I already set up the proportion for us. So side LN needs to be proportional to side SU. So that's this side LN, that needs to be proportional to side SU right here. And then side MN needs to be proportional to side TU. So that's our right side of our triangle and the bottom side. So it says fill in the segment lengths. So we're going to go ahead and fill that in. LN is 4, SU is 20, MN is 3, and TU is 15. So to figure out if these side lengths are proportional, we need to find their cross products. So it says, are the cross products equal? We do 4 times 15 first, and 4 times 15 gets us 60. And then 20 times 3 next, and 20 times 3 is 60. So yes, those cross products are equal. Does that mean that the sides are proportional? Well, yes, we talked about that if something is in proportion, then the cross products will be equal, so this is yes. So are these two triangles similar? And we can say yes, since their sides were proportional, they are going to be similar here. As we move on to our third page, there are 4 steps to determine if two figures are similar. The first is to take the first set of corresponding sides and write them as the first fraction of our proportion. Then you take the other set of sides of corresponding sides and write them as the second fraction of the proportion. Then we cross multiply, and if it forms a true proportion, then the fractions are equivalent. Then the figures will be similar. So that's our steps to determine if something is similar, but we're going to go ahead and say, well, if these ones are similar, then which is going to replace x? So we need to set up a proportion thinking that these are similar. So I would first just mark each of those corners to represent those corresponding angles. So we had A and A, so those are actually the same angle right there. They're both kind of embedded in one another. And then we have B and D, so we're going to highlight B and D. And our last set of points, we have C and E, and those are going to be labeled right here. So it's saying that the sides need to be proportional in order for these to be similar, so we need to set up a true proportion. We have AB over AD. So AB is this whole entire side length, and AD is just this little one right here. So then X, we don't know what that needs to be yet, is to AE. So our first one on top here came from the big triangle, and it was this whole the left side of this triangle, and that was in comparison to this left side of the smaller triangle. The right side of the smaller triangle was AE. That means that that X value needs to be this whole right side of our bigger triangle, side AC. So we're going to circle B for our answer there. Now in number 2, it says the two rectangles are similar. Which proportion could you solve to find the missing side length? So they're already telling you that they're similar. So we know that we're already going to have 2 sets of corresponding sides. So I'm going to say X is the same as 4, and just since it's a rectangle, we would know that these are also the same measurements. And then that means that this bottom side is going to be corresponding to the bottom of the smaller rectangle as well. So we can go ahead and highlight those, or you can mark them with the tick marks if you don't have multiple colors. And now we can set up a proportion. So if we look at this first one, 4 over 15, that's taking this side length and the bottom, and then they're saying 22.5 over x. Now that's not quite going to work because they took, here was the side and here was the bottom. Now here, this is the bottom and that's the side, so their units aren't lining up, so we don't want that one. In C, we have x over 15 equals 22.5 over 4. So if we put x over 15, that's a side over a bottom. And then over here they have a bottom over a side. So again, their units are not matching up there. In B, we have x over 4 equals 22.5 over 15. So we have a side over a side equals a bottom over a bottom, and x and 22.5 did come from the same rectangle, so this proportion looks good. Let's go and double check the last one then. 4 over 22.5, that's a side over a bottom. And then they have a side over a bottom, but they're coming from different rectangles in this one, so that's not going to work. So B is going to be our answer there as well. In our last set of examples here, it says we have the steps to find a missing measurement. So you would have to determine the corresponding sides first, set up your proportion, cross multiply to solve for the missing length, and then label your answer and check your work. So in this first one, we have what must the value of x be so that the figures below are similar. And remember, for figures to be similar, their sides are proportional. So we're going to set up a proportion. But I think first we need to determine the corresponding sides. So we can say 8 and 8 right here. Those are corresponding to x and x in these ones right here. Pretty easy to see there. And then the shorter side of this trapezoid is the top of it. That's going to go with the top of the other trapezoid. And then the bottom side of both of these are going to be corresponding to one another as well. So again, you can highlight them or use tick marks to show. And then we're going to set up a proportion. So we could either set up using 8 over x, that's going to be the side over the side from each trapezoid. And then we could set that equal to 10 over 15. That's going to be the top of this trapezoid over the top of this trapezoid. So that's one way we could do it. Or you could set it up, start again with 8 over x, and then you could use the bottom measurements as well. So you could say 8 over x equals 14 over 21. Either way, it's going to work, but let's go ahead and solve them to make sure. So we're first going to cross multiply. 8 times 15 gets us 120, and x times 10 is written as 10x. To solve for x, we divide by 10 on both sides, and that's going to get us 12 equals x. And we're just going to double check that that works on the other proportion as well. 8 times 21 equals 168. X times 14 is 14x. We get x alone by dividing by 14 on both sides, and that's going to get us 12 equals x again. So it looks like 12 is the correct answer, and that's one way we can check is by doing it both ways and make sure we get the same number from each proportion. And the last part said label your answer, so it's going to be 12 centimeters because they were measuring these trapezoids in centimeters here. So don't forget to put a label on your final answer. Moving on to number 2, this is a pair of similar triangles. Write and solve a proportion to find side DE. So we're looking for this side DE. They've already marked our triangles with these lines to show which of these angles are corresponding to one another. So we can go ahead and highlight the sides to find the corresponding sides. So AB, that's going from this 1 tick mark to 2, so that's going to be side DE over here. And the 2 tick marks to 3 is this side BC, so that's going to be EF on this triangle. And our last side that corresponds is AC to DF. So we can go ahead and mark those sides. And then again, we have 2 options for setting up our proportion here. We need 10 over x in both of these because that'll help us find our side length that we're missing. But then we can choose either the blue sides to compare it to or the purple sides. So setting up one, we could do 6 over 12. Or over here we can say 10 over x again is equal to 7 over 14. So those are the 2 ways you can set it up. We're going to cross multiply to check both of them, make sure we get the same thing. So 10 times 12 gets us 120, and x times 6 gets us 6x. So we set those equal to each other, and we divide by 6 on both sides. When we do that, we're left with 20 equals x. And we'll go ahead and check it in our other proportion. 10 times 14 is 140, and x times 7 is 7x. Divide by 7 on both sides, and when we do that, we get 20 equals x. So since we got the same thing on both, that's enough for checking our answer. We verified it in both proportions that we got it right. And in this case, these numbers were not labeled. They didn't tell us any sort of units in this problem. So we can just say side DE equals 20 since we don't have a label for this. And there's our final answer. So as you continue practicing with these types of problems, just remember that order is important and that it's important to mark your corresponding sides and corresponding angles so you don't get confused with what you're setting up when you make your proportions.